Hello people, here we are at Titan Machine Tool, back working on this chuck adapter thing. I'm going to show you what we got going on. We're going to actually make some chips today. Well, I should say in this video. But before, I just have to show you some things that you have to be careful of when you're working with this chuck divider, spacer, super spacer head thing. So now when we're drilling holes, we're going to drill holes through. All right, so when we drill through, we have to make sure that where we're drilling through, we're not going to hit the chuck jaws. Okay, so that was the first thing I did now. What I did was I came over here to my program, and you can see where all my holes land. And I said, all right, well, if I look at this, where do my jaws need to be? And you can see the blue one, where I'm on the blue one right now, that's a simulation of one jaw. So I said, all right, well, obviously I can't have it over here at this 90-degree section. I said, well, how about on this one right here? So I drew the other two lines 120 degrees apart to simulate where the other chuck jaws were. So I said, all right, well, if this one is over here and the other two are over here, I'm safe on all these 1/4 holes on the outside. All right, so now when it comes to drilling these holes on the inside right here, I'm still safe because this first hole that I'm going to put in would interfere. None of the others will, as you can see right there, even with the counterbore. Obviously the counterbore don't matter because I'm on the top, I'm not going through. With the drill hole, make sure it doesn't interfere with where that chuck jaw is. Now you got to also allow for the fact that the chuck jaw is a little wide, so we could be close on this one right here. So we just have to be careful when we drill through that we're not going to hit the chuck jaw. But it looks like most of these are going to be in a safe condition. And this one, even though it looks like it's going to hit, it's inboard. See, the chuck jaw stops around here somewhere and then it steps down again. So once we're over here, we should be clear of that jaw. So if we look at the part right here, that's how we have it set up. We have it set up at 90 degrees this way. And when we go to put that hole in over here, if we had a hole, a 1/4 there, we'd have a problem, but because that 5/16 clearance hole is in here, the chuck doesn't stick, the jaw doesn't stick that far out. So we should be good. We'll always make sure when we go to do it that we ain't gonna crash into the jaw. So that's how I set that up, to make sure that the jaw timing seems to be in its best orientation to not interfere when I drill through. All right, so let's make some chips. Set you up over here as observers, courtroom observers. We'll see how this goes here. I'm just gonna narrate while I'm doing what I do. Let's get this thing as close as possible and be able to see. I can't see. Try that. All right, so I got a number 4 center drill in there. First thing we're gonna do is we're going to center drill the 1/4 tapped holes. Those are through holes. Tap drill size for a 1/4 is 213, number 3 drill. The body of a number 4 center drill is like 5/16. So we're gonna drill that deep enough to where we have a nice chamfer on the top of that hole, so when we tap it, there'll be no burr. So it's going to go to its first position to drill. So I'll bring this down, I'll touch off on here, and I will zero my DRO on my Z-axis. You can't see that because the camera's stationary today on the tripod that one of my fantastic viewers sent me. Thank you very much. So my tip of my center drill is at Z0 right there, and I'm going to proceed to drill like 290 deep, which will leave me a chamfer on the top, maybe 300 deep. That way when I do the 1/4 tapped hole, it'll already be chamfered. I'm using cutting oil. I'm only running about 1200 RPMs. A little dab of oil here. So it's 290 deep from the point of the center drill. Oh yeah, and when I set this up, not only did I indicate the bore, I did all this at one time. I turned, I faced, I did the counter face, I bored, I did all of that at the same time on the lathe. But nonetheless, when I swept this bore, I also swept this one too, just to make sure we were good. Because whatever's going on here is going to be lining up in this bore. So I swept that just to make sure I was within tenths. I mean, the resolution on my indicator is only half a thou, so I think I'm okay. But after I swept it like this for center location, XY center location, I also put the indicator in to sweep the top of this just to check and see how flat it is. Like I said, this is not the most precision item out there, but this way I had 0, 0. This way I had +1, -1. I think it's satisfactory. So satisfactory for what we're doing here today. So back to drilling. I should say center drilling. Deep. Give and take a little bit. Saves me an operation. I get a nice chamfer with the center drill and I don't have to go back and then do them again by hand. All right, I'll clear the chips. That's what we got. Next thing we're gonna do is we're gonna center drill the bolt holes in the counter face. But I'm gonna change center drills. I'm gonna move up to a larger center drill, being that those holes right there are 5/16 through, actually 3/28 through, with a 590 counter bore. So we're gonna go up to a bigger tool to take a little bit more material out. And leave a bigger spot, bigger countersink, more material removal essentially. Same deal, so I changed to a larger center drill. I'm gonna come down, touch the pot, zero my DRO on the Z-axis. Now I'm gonna proceed to drill that bolt hole circle. Because it's gonna have a counter bore on it, the counter bore is 590 deep. This center drill, number 5 center drill, number 5 center drill has a 7/16 body diameter, so I can drill 400 deep, 430 deep, because the counter bore is going to be larger than the chamfer left behind by this tool. But nonetheless, it takes a lot more material out for you. So here we go, first one. Here we go, 420. 420 deep. Let's smoke it. Foggy out today. Oh yeah, take a deep breath of that. Breathe deep, baby. 420 deep. Let's say this was a number 5 center drill. The pilot diameter on this tool is like 3/16. 3/16 pilot diameter, 7/16 body diameter, I think. So now this is the one we have to make sure when we drill through we don't hit the jaw. It's the one that looks like it could be the closest. Clear the fog. I always peck. I go in, peck, come out, clear the chip, apply some oil, drill some more, peck, drill, come out, clear the chip, apply some oil. Or 20. I'm going to take the center drill out. I'm going to put in number 3 drill. That's the tap drill size for a 1/4-28 tap. Number 3 drill is 213 in diameter. So now I'm going to back my program up and go back to my program for the outside holes. So now these are through holes right here, so I'm going to drill through. The same deal, I'm going to bring the point of my drill down just to touch the part right there. And I'm going to zero my DRO. That's digital readout in the Z-axis. That way, as I'm drilling, I can see when I'm going to come close to breaking through the other side. The flange, this flange is 1 inch thick this way. So I know if I'm already a little bit below the surface when I go into the hole right there. So if I call that 0, I know when I get to 900, 950, I know I'm going to come close to breaking through the other side. You always want to be careful when you know you're breaking through the other side, because sometimes when it pushes the burr through, it pushes this real, especially stainless steel, pushes this real nasty burr out the other side, and it grabs hold of the drill, and you'll snap the drill off just as you come breaking through the other side of the part sometimes. So I'm just, word to the wise, just be careful sometimes. Like I said, 1018 is pretty easy going. It's not that problematic, but if you were drilling Inconel or 316 or some real nasty stuff, be wary of those big hanging burrs. There again, I'm going to just brush the drill with some cutting oil. I have spray mist. I don't want to set the spray mist up. It's going to make a mess right now with the camera. Plus, I'm doing steel. The tools like oil better when you're doing steel. If it was aluminum, a little more forgiving, we'll just use the oil here and drill these holes. It's a peck drill. Allows the chip to come out. Doesn't pack up in the hole. And we keep the drill moist with nice lubricant. Everything works better with lubrication. So now I can see my DRO, I'm at 870, and I can actually feel that I'm about to break through the other side. So there we go, I'm through. I'm gonna set my stop. You can't see me, but I just set my stop on my quill so that I hit the stop every time just after I break through. And I really don't have to watch my DRO at this point. The quill stop is set, so But there again, I'm mindful of it so that I know as I'm getting close to the bottom of the hole, be careful on the breakthrough. Through. Next position. Dab of dual oil. Smoky, smoky. I should have a foghorn simulator. Since you think we was out on the coast at the point. We're out at Point Judith today at Rhode Island. It's a cloudy, foggy day. There's the Beaver Tail Lighthouse, the foghorn. Now this cutting oil is supposed to be non-toxic, safe. It's not going to kill me as fast as everything else. Because this video is going to be kind of long. It'd be nice if I was smart enough to know how to use this fancy video editing software and I could just speed it up. All right. These are all done now. Tap drilled, 213, number 3 drill for a 1/4 tap. We'll be tapping those later, okay? These guys are gonna be 3/28s, but I don't wanna plow a 3/28 drill through one smash. I probably could, 1018, mild steel, it's soft. I'm not trying to set any land speed records here, so I'm gonna use this same 213 drill, and I'm gonna rough drill all these holes. And then I'm gonna put the 3/28 drill in and drill them and then I'll go and counterbar them. So here we go. We're gonna do them guys now, them gals. So that was just convenient to use that drill. It was already in. My stop is already set, so I know on the Z, the quill stop on the Z is already set, so I know when I'm breaking through the other side. This one here, we'd be mindful because there is a jaw over here, but we should be well inboard of it, but we want to make sure. Don't want to find out the hard way. So far, so good. We have to be mindful again when we go to a larger diameter drill. That one might have cleared, doesn't mean the bigger diameter one will. I don't know how exciting this video is, but doing something different today. Taking advantage of the tripod, right? Couldn't do this when I was holding the phone, holding the camera. I have to grow an additional appendage that I can hold on to that camera with. And now we're making chips with 2 hands. Probably could have stopped the video, drilled all the holes, and then just came back and said to you, hey, look, I drilled all these holes already. Same deal. We got to make sure this one, here again, make sure we don't hit it. We should be well and bored. No issues there, probably. Here we got 2 of them here. I guess we had 2 of them on the other one as well, huh? All right, play the chips. .328 drill. .328. What's that measure? 328. That's 21/64. So I'll run that program again. I have a bolt hole circle program. Come back down. And again, we'll touch off. Same reason. Zero my DRO just so I know when I'm getting close. We're gonna make a lot of smoke. Let's slow it down. It's gonna be smoky. I gotta move my quill stop down. Finish drilling through. How close we getting? Oh, there we go. We broke through the other side. Set my quill stop. Well through the hole. Next hole. So now here again, we gotta be careful. We don't want to hit the jaw. We could be close. Let's hope we're not there. I don't want to break it. Oh, I'm getting close. Let's see. Are we gonna hit? Oh, we're good. You would have known if we hit because the as hard as the drill bit is, it would not have liked bumping into that hard jar, and it would have made some ugly noises. So I slowed this drill down though, like 600 RPMs. Again, I'm coming through here. We cleared on that one, so we should clear on this one as well. Fingers crossed. All right, we're good. We made it through. Next thing I'm going to do is I'm going to run that same bolt pattern over again, and I'm going to rough all of these counter bores. Alright? We want a 590 counter bore in there. 591 diameter counter bore by 316 deep, 312 deep. You need to be able to sink a socket head cap screw, 5/16 socket head cap screw in there. So first thing I'm going to do is I'm going to rough these counter bores out. I don't like plunging the counter bore just straight up with an end mill. I mean, you can a lot of times, but I like my stuff to look nice. I want it to look good. I want the bottom of that counter bore hole to be flat, you know? The bottom of a end mill, unless it's ground as a flat bottom end mill, is really not flat. It's not perfectly perpendicular to the side of the end mill. A lot of times, the leading edge up here is more proud than the center. So a lot of times it has an angle on it like that. Now when you're only putting a socket head cap screw in there as a counter bore, probably don't mean squat. But that's just how I do it. So I'm gonna rough bore all these with a 9/16 tooth flute end mill. Now, you don't put end mills in drill chucks, okay? But I'm sinking this guy all the way up in here, and I'm using it as a counter bore. I'm plunging this way with it, down straight up, and the pressure's coming straight up. You never, ever, ever want to use an end mill in a drill truck and side mill with it. That would be completely hack. You know, doing this saves me from taking this guy out and having to put it in a collet, but being lazy is more so than what it is. But yeah, like this, if you're using it as a counter bore, not so big a deal. But you definitely can't do this in side mill. So now, like I said, this is for a 5/16 socket head cap screw, so the depth of the counter bore needs to be at least 312 deep. I like to go a smidge more. So I'm gonna zero my DRO on the Z-axis right there. I'm gonna slow this guy down a little bit more. I probably could run it at 500, but it'd just make a whole ton of smoke. It's gonna make a ton of smoke as it is. So we'll put this at like 250 here. And we're gonna go finish it at 315 deep-ish, finish that. So if I go 310 deep from here, I think we'll be in good shape roughing it out. 560, 565, it's probably gonna cut a little big. You know, and now you watch this chucking head might vibrate. Like I said in the last video, this thing is not the most robust holding device. So, I don't know. Let's see what happens here when I counter bore, if it vibrates like hell. So I'm going to go 310 deep once I make contact. Play the chip. Alright, so that's 310 deep. It wasn't so bad. I got a little more aggressive with it. .310 deep. Now I could switch. I do have a 590 end mill. I could switch right to a 590 tooth fluid end mill and counter bore these things and probably be done. But instead I'm going to circle interpolate a pocket on every one of these counter bores with a solid carbide 3/8 spark fluid end mill. video's got to be getting pretty damn long. The phone's gonna explode trying to download it. 310 deep. Careful of them chips. Things are out to hurt you. Especially if they're stainless steel. Have a pneumatic drop off, that's what you hear here when I'm changing the collet over. I got a 4 flute solid carbide end mill here. So I have a circle pocket program. Just gonna position over. This video's gonna be getting really long. Crank the knee up here, might screw up the view. Might have to readjust the view here. I don't know. Let's take a look-see. Oh no, I guess we're still safe. Oh my goodness, 32 minutes long. Good golly. Crank that up a little more here. Alright, so I am going to bring my quill down. It's sticking out a lot further than I'd like to. I ordinarily would never stick it out this far. Let's crank it up a little more. I just don't want to obstruct your view. I guess we're still safe, right? We're still safe. Ordinarily, your quill, right here, this quill piece, you'd like to keep that choked up in the machine as much as you can. Obviously, when you're drilling, you have to come down. Whenever you have to mill, you don't want this thing hanging way out. I'm not taking a lot of material. I'll be taking like 5 or 10 off the bottom at the most, and 5 or 10 on the side. So it's not a big deal here. It's a nice sharp tool. It's going to cut this 10-18 material, no problem at all. But as far as rigidity, chatter on your finishes, stuff like that, tool wear, you'll get greater longevity on your tool if the spindle is nice and robust and tight and you're not getting vibration and chatter. So don't stick this out is the point I'm getting to. Choke it up as much as you can. Now I'm going to stick it out way further than I should just so that I can do this video. So there again, I'm touching that surface. I'm zeroing my Z-axis DRO. I changed to open speed. I'll run this baby at about, I don't know, 1400 RPMs. I don't have my spray mist. The spray mist would be nice to have right now for cooling. So, hold on, let me go get a spray bottle. Alright, so we got a spray bottle. We'll use this. Spray mist. Alright, call up the tool, 3/8 tool. It's reading the tool geometry. It's going on center. Oh, wait a minute, let me check my program, make sure I'm not running this baby too fast. Alright, we're good. We're pussyfooting. Same deal, cue it up, tool geometry, it's ready to go. It's telling me to set my Z-axis. I'm going to set my Z-axis to -317. I could feel it make contact where I hit 310. All right, here we go. A little spray mist. Let's go. She's cutting. 1600 I cranked it up to. That's a circle pocket. Goes around, starts in the middle, slowly wakes its way around. It knows how big the tool is. It knows if it's using cutter right, cutter left. Makes its way around. I told it to leave, I don't know, 5,000 finish pass, and that's per side, that's not on the diameter. You know, maybe 3, I don't remember. We're only running at 2 inches a minute. pussyfooting. Doesn't have a lot of area to travel. So now it's done. And when it's done, it moves off the edge of the part. We'll take it out. We'll go to the next hole, but before we do anything, we're gonna turn the spindle on. Give that a visual inspection. Take a peek. Looks okay. Let's see if that measures close to 590. Yeah, we're about 589, 588 and a half. Tool's got some wear on it, so you know, you put a little cutter comp in there. You tell it was 374, 373 or whatever, but I think we're okay for this right now. We're already running the video too damn long. Come back down. And go back down to like 317. Little spray. Scoop, scoop, juicy, juicy. Start her up. Start cutting. There we go. She's cutting. Alright, this video's already too long. I think you got the idea of what I have happening here. Just using the circle pocket over and over again. All I had to do was program the first circle pocket at that first location right there. And then I have a feature called rotate. So it asks me what events I want to rotate. Oh, what do they call these things? Events? Or... So all I had to do was tell it the first one. I told it all the information for the first one, and then I told it to rotate all of this on the XY center line, XY 0 center line, how many degrees apart, and how many times I wanted it, and it put them all in for me. So we're not going to watch it cut all of them here. This is obviously the longest video I got. I don't know if you guys like this stuff. You like watching all of this, sitting here for 35, 40 minutes, listening to me blab while the tool's making chips. Let me know in the comments if you do. I don't know if I have the attention span to sit and watch this long, listening to somebody like me talk. But nonetheless, this is what you got in this video. So I'll finish doing all of these. I'll go back, I'll clean them up. I'll use a countersink. I'll go back, countersink all these holes. I'll countersink them on the bottom of the counter bore. I'll countersink the top of the counter bore. I gotta tap all these quarter 28. And then when I'm all done, I'll flip it over. Same deal, I gotta deburr the back side. Alright people, thank you for watching. Titan Machine Tools signing off for today. And I appreciate your viewership. Subscribe, please. Thank you.